Bonjour et merci de participer à cette 12e journée de DataXDays. Les prochains deux talks ils parleront de Delta Lake. Nous allons commencer cette section avec Saafi, il est architecte de solutions chez Databricks. Il va nous parler aujourd'hui sur l'option de donner reliability au Data Lake, le Delta Lake. Merci beaucoup, Saif, et le public est à toi.
Global company building and providing our customers with a unified data analytics platform to accelerate innovation by facilitating the collaboration and the work of data engineers, data science, and analytics. We have more than 5,000 customers and 450 partners, and Databricks is actually the company behind Apache Spark, but also the very known, well-known data processing platform Spark, but also the company behind Delta Lake that I'm going to be presenting today, but also MLflow, the framework to standardize the lifecycle of machine learning. So let's jump into today's focus, that is Delta Lake. So what's the common challenge that we saw our customers facing when they build their data lakes? So basically, we saw them, a lot of customers has been through the recent years and the last 10 years collecting a lot of data, pushing it into their data lakes, whether it's like customer data, IoT data, sensor data, all kind of data that is available, pushing it into their data lakes in order to derive insights. Like the aspiration and the objective was actually to derive insights using analytics and using Spark, because this is big data in most of the cases. But problem is, in most of the cases, it was very hard because data was unreliable. Like it was very hard to process this data, very hard actually to make sense of it and to use it because of a lot of certain challenges that I will explain further. So what are the common challenges that we see when it comes to reliability? So one very important one is that we see most of the time is the lack of atomicity when it comes to data lake. Data lakes, we are dealing with file data. And sometimes jobs that we are defining to transform the data fails and they leave the data in a corrupt state. And this would require a lot of refining and a lot of work to recover from this state. The second one is the lack of quality enforcement. So if you take a data lake using Parquet, for example, and you have a date column, you think that you are writing dates, but some changes may happen actually, like the format of that date, the value that you're receiving might change, and your data lake will accept any value that is getting into the system, and you'll find yourself with data that is actually mixed between different formats, and you will not be able to even use it or parse it again. And the third one is kind of very complex, is the lack of consistency. We find ourselves using the Lambda architecture with the data lakes to handle real time and also batch. So there is no consistent view that you can have, and there is also no an easy way to be able to combine batch and streaming. But also one of the most complex challenges that we saw is how to handle incremental updates. If we have a delete, for example, to be compliant with GDPR, if we have an upsert, an update that we want to add to our data, it's very complex. It's not an easy operation. And we saw a lot of customers actually building kind of frameworks, complex frameworks, to be able to manage these incremental updates. So this is when it comes to reliability, but we saw also some performance challenge to use data on data lakes. One of the very common problems is the small file problem. If you have a streaming use case, you'll end up with a lot of small files. Even if you have daily incremental updates, you'll find yourself with a lot of small files, and this is not very efficient when it comes to processing these files later. The second one is partitioning. You start your data lake using a certain kind of partition, but this can break very easily because you might end up partitioning with a column with high cardinality. You might end up querying using another index, and you will need to rewrite your whole data. You need to manage how to repartition again, and that's not easy. And the third point is like especially specific to cloud storage. When a lot of customers migrated to the cloud, well, they find a difference between the throughput of data when it's like saved in SSDs on premise and data that is on the blob storage on the cloud, whether it's S3, GC, like on AWS, or like blob storage on Azure. Like the throughput is not the same. So we'll have to improve that throughput, and there is no caching mechanism that is handled automatically by the framework that we are using. So to solve these issues, we build a format that's Delta Lake. So Delta Lake is an open format that is like in production for more than 3 years. It was open sourced just last year and donated to the Linux Foundation. It relies on Parquet under the hood, like it uses Parquet files, and it comes with transactions. So it's transactional layer on top of your data lake, and it's fully compliant with Apache Spark. So Delta Lake, the aim of it is actually to bring this reliability and performance to your data lakes, to be able to derive analytics through data science and also machine learning. So what are the features of Delta Lake? How we ensure data reliability? Well, first, if you look at the heart of the system, well, Delta Lake is actually a Parquet file with a transactional log. This transactional log would ensure the atomicity of the operation that we're executing. So whenever we write, like we do a write operation on our data lake, we will ensure that whether it writes completely or nothing would be written into our data lake. So this ensures that there is no corrupt state and there is no intermediate state. So we have either the full operation done or nothing. Atomicity is very important, and this gives us kind of features that we find in the data warehouse world. So we are bringing the data warehouse features into the data lake. What we can do with these features, so you'll have this transactional log, it will help us then implement and be able to use Delta Lake tables with batch and streaming. So one important feature that I'm going to explain also later, the Delta architecture, we break the Lambda architecture by combining batch and streaming on the same tables. And you'll also be able to do update, delete, and merge on the data lake easily, and replace the complex operation that you used to be done. So key feature to be noted then also aside the ACID transactions, the schema enforcement, and this is very important to guarantee the quality of the data, but also time travel. And this is important to do some audit log and trace what is happening actually in our data lake. Through time travel and audit operation, you can do describe history on a Delta Lake table, and then you'll be able to see all the historical operation that has happened on your Delta Lake. And you can audit these operations, but you can also revert to a previous version. If you want to query the data as of 7 days ago, it's just as easy as like executing a query with time travel, like with the timestamp, and you will get the data, the view of your data as it was 7 days ago. Then it comes like performance optimization. So some performance optimizations comes with Delta Lake. So it's worth noticing that most of the reliability features will go to the open source world. Most of the also optimized features are kind of specific to the Databricks managed Delta Lake. So what are these features? We'll use some indexing algorithm called Z-ordering to collocate files like values on the same files, and this combined with data skipping will help actually accelerate queries. So when you have a predicate query with a filter and a predicate on it, it's kind of very fast. Instead of scanning the whole data lake, we will just select and open the file that matches that predicate, and this accelerates tremendously the queries on your data lake. We will also compact the files. The small file problem will no longer exist because we will compact automatically the files into the optimal size. And you will also implement some caching that is very enhanced to bring to accelerate the data processed on the platform. So this will help tremendously to improve the experience and the queries that you run against your data lake. So now, how this architecture would lay out. So let's take a look at what is happening currently. If you have, for example, a data lake using Parquet file. So if you have a streaming case, you will have data used with Lambda architecture. You would have first like data streamed into your analytical dashboard in real time. You add and also data that is saved on your data lake. You add validation in both steps. Then you have to repartition. If you have an update and merge, you have to add another job to produce another table. Then you have your reports. This creates a lot of latency, create a lot of overhead of management. You have a lot of operation to manage and schedule, and it's kind of complex. So it ends up kind of like a lot of customers going away from this because it's really not easy to manage. So what you propose with Delta is kind of Delta architecture, what you are seeing in here. Well, then get your data in your data lake. So it's kind of bronze, silver, gold, let's say, pattern. You can have as many layers as needed. Actually, this is just a conceptual, let's say, architecture where you have the raw data in your bronze layer. Then the data will go from one layer to another with the quality that is improved. So Delta Lake would allow you to incrementally improve the quality of your data until it's ready for consumption. So how it happens, so just get the raw data, get the data, whatever it is. The advantage of Delta Lake is that it supports unstructured data with structured data. So you can put video, images, JSON file, structured file. You can combine any kind of data into your data lake. It's not just restricted to structured data. You have all open format that you can use, dump them into this raw zone, landing zone, and then keep them for years, like just minimum parsing. This is like brute, like raw data. Then start working on that data. Add some, let's say, clean up, some parsing. We can add schema enforcement on top of it. Then it goes to the silver layer where it's easy to, let's say, to query it, to debug it. It's still granular. We can work on it. Most machine learning and data science workloads will go into this silver layer to start working with the data. Then once that layer is ready, we can move it to, let's say, a more clean view, call it gold. It's a view where it's ready to be served for business analytics. So it's mainly usually kind of aggregated view of the data with business logic on top of it to be able to derive insights for the business. And this data can be actually queried not only by Spark, but also by Presto, by Athena, by Glue, by other external systems. It's not just logged into Spark. The idea of Delta is an open source, and there are not only a Spark connector, can read it even with Hive and any other external tool to gain insights out of it. All of this, let's say, flow is guaranteed, like you get it with a full ACID guarantee, meaning all the transactions are atomic between the different operations. They are open source and they are actually powered by the Apache Spark API. So mainly the most common ETL that you're using is Spark, so it's easy to plug it into your common ETLs. And also it simplifies the management of your workload. And now you can see the data as streams that are moving through your data lake. So this is kind of, eliminates the management of scheduling complex job. You can see your data moving from one zone to another. Like we try to push our, recommend to our customers to not think in terms of, let's say, batch or streaming, but get the data where it needs to get, and then start moving it from one layer to another to be served to the business. So data is moved through the data lake to be served to the users, and then you can define like these streams to trigger them. Like either you want daily trigger, you want to have every hour trigger, you want to have a micro batch every second trigger. That's up to the SLAs and the requirement that you have for your analytics. And also this will support having inserts, updates, deletes. So it's easy if you have, for example, a new record to insert, you can just using SQL command to just insert to that record into your table. If you have GDPR compliance to strategy to implement, you can just add these delete commands into your data lake and it will work because it supports delete operations at like single row level. But you can also do incremental update. Like incremental update is one of the most complex operations. You can just do a merge statement and it will incrementally add this new data if needed or just insert it. So this is very important for GDPR, for also correction and these kind of operations. Then it becomes easy to recompute any new business logic. So if you update your business logic, you can just like delete your silver and gold table, and then you push your new code, the new version of your code, and then you start your streams, and it will create these new view for you with the most recent, let's say, business logic that you implemented, and it's kind of very easy to manage on your site. So this is the Delta architecture. Hope it's clear and it simplifies things for you. to get started with Delta, it's very easy. So instead of using Parquet, you can just say create table using Delta. It's data format, so it's very easy to start with, and it's compliant with Spark API. So if you have data frame, Spark data frame, if you have data frame.write.format Delta, and then it will save it into the location that you are looking for. So it's kind of easy. And also, if you have a current data lake using Parquet, you can convert it to Delta easily without rewriting the data. On the second step, you can optimize it if you use the optimize command. So it's kind of easy to start with Delta and also optimize the layout of your files. So this is the merge operation that I mentioned. It's kind of one of the most critical features of Delta. It helps you, like if you have an update table and an existing, you want to merge it into an existing table, just with a simple SQL command, you can say merge into your destination table using the update data frame, and then specify the condition. So if the keys matches, then you update. Then if it doesn't match, then you insert. So you have the full flexibility to define what kind of operation to execute when there is a match and when also there is no match. And also you can do time travel. So you can time travel. So this is very important. As I mentioned earlier, you can do select star from table timestamp as of. So you specify the as of timestamp or as of version of your table. So this would help you if you need to do a rollback because of an accident, bad write, you can do it easily, and you will be able to do a rollback into a previous version. So, and you can do it either like with any API, like with the Spark, whether it's a SQL or Scala or Python API, it's compatible and you can do it easily. And this comes, as I mentioned earlier, with a full audit history of the table. So there is a lot of customers using Delta. There are a lot of customers using Delta, and mainly like a lot of the advantages that comes with it is around improving the scale and the performance of your jobs. So this case, this is Comcast. So they give them, let's say, more scalability, but it reduces the costs of their job with using Delta and simplify the management of their, let's say, streaming workloads. We are almost at the end of the session. We still have 2 minutes. I'll be happy to take any questions if you have any, if you want to learn more about Delta. Merci beaucoup.